Welcome to part 5 of this 12-part Python tutorial series for beginners. In this chapter, we're going to learn about lists in Python. A list is a data structure that allows us to store and work with a lot of data at once. So far, we've only been dealing with single individual pieces of data. But in the real world, it's far more common to have data that appears as part of some collection or sequence. And if you look around, you'll find examples of this everywhere. For example, this could be a collection of shopping products stocked by an e-commerce store. Or it could be sequential episodes of a TV show on a streaming service. Or it could be items inside a video game. Towards the end of the tutorial series, we're going to be building an app as well. And in our final project, we're going to build an expense tracking app, and we'll need a way to represent a sequence of expense items. To deal with situations like this, we'll need a way to handle collections of data. In Python, the data structure we can use to do this is called a list. In other programming languages, you might hear them being referred to as arrays or vectors, but in Python, we call them lists. To create a list in Python, we can use these square brackets here. So here's an example. And because a list is sequential, the order that we put things into a list will matter, and the list will retain that order. So here I'm creating a list called fruit basket, and inside the list I've got 3 strings, an apple, banana, and a carrot. And that entire list can be accessed by using this variable, which I've labeled fruit basket. Items inside a list don't even have to be related. You can mix data types within one list. So you can have a list of strings, numbers, and booleans all in one list. Although normally I don't recommend doing that, I tend to prefer lists that only stick with one data type. And that's because I think that there's very few situations where something like this would make sense. To access any of the items in the list individually, you can also use the square brackets. So to do that, you type the name of the list, in this case it's fruit basket, and then open the square brackets, and inside those brackets, put the number of the item you want to access. This number is called the index. It corresponds to the position of an item in a list, which is why at the beginning I said that the positioning matters. Except that this number starts counting at 0. And in fact, in most of computer science and in Python, you'll find that most things start counting at 0. So 0 is actually the first item, not 1. So here, 0 corresponds to apple, and if you put 1 in the index, it will correspond to banana, which is the second item. And then if you put 2, it will correspond to carrot. So let's just hop over to our code editor and give that a quick try ourselves. We'll create a list by just declaring a new variable, call it fruit basket, and then we'll open our square brackets. And if we don't put anything inside, this will just create an empty list. So let's print that, and then run it. And here we have an empty list being printed out. And now I can put items inside, so let's put some strings in there. And I've put some emojis inside my fruit basket. I'm using emojis because I feel like it's easier to visually learn when we do things to the list this way. And here the emojis are just strings. But if you have trouble typing the emojis, then you could just type a normal string as well. And so now when we print it out, we can see the individual items inside the list. And there's 3 items. By the way, the technical term for each of these items is an element. So that's one of the ways you can refer to an individual piece of data inside the list. And now let's try to access an individual element within the list. So let's say that I want to access this banana here. So this is the second item, which means that I have to use index 1. Because remember, this is 0, this is 1, and this is 2. We start counting at 0. So I'll open my square brackets, and then I'll put 1 to access the banana. And then if I run that, now I can see that only the banana is printed out. And I can use this as a normal variable as well, so I can do something like create a banana variable, and I'll store the results of this in here. Or instead of banana, I can just call it fruit, like a single fruit, and then I'll print out that fruit. So when I run that, I get the banana, and then if I change it to 0, I get apple. And what happens if I try to call an index that doesn't exist in the list? So 0, 1, 2, and 3. So if I try to put 3, obviously I don't have that next item. My maximum index is 2. I'll get an error. It says list index is out of range. So if you ever do something in Python and you see an index error, it's most likely that you tried to access something inside a list that doesn't exist. So you have to check if your index is the correct number. You can even have list within a list. So this is the case where each element inside your list is itself a list. This is common for when you want to deal with data in 2 or more dimensions. And in Python and in computer science in general, we refer to this concept as a 2D list or a 2D array. So here's what a 2D list looks like. It might look confusing at first, but if you look really hard at it, it's essentially a big list with 2 elements, and each of those 2 elements is itself another list. So it's kind of like nested list. And again, I said that this is useful for things where you want to deal with data in 2 or more dimensions. Typical use case of that is if you want to do a grid, like a chessboard, and you want each piece or each square to have a number to represent whether there's a piece on the board or not. Now, how do you think we can access the data in this list? Have a think about it, because it's not so different from what we saw before. And you pretty much just do that the same way by using the square brackets, except that you kind of need to use them twice, because the first time you use them, you get 1 element back, which is, the nested list, and then you have to use another set of square brackets if you want a specific value from that nested list. So let's go to our code editor and try that out. So let's save this and then run the file. And you can see it's actually returning 1. So that's what we wanted. But just to show you what happens, if we take out the second set of brackets and then I run that, grid 0 actually returns that entire list. So you could think of this as a list itself, and that's why we can use the index syntax again. And then if I change this to 1, you'll see that I get that second row of list being printed. Don't worry if this seems a little bit confusing. It took me quite a while to wrap my head around it at first as well, and we won't be needing to use anything like this anytime soon. So don't worry if you don't get it right away. The only reason I'm mentioning it this early is that so if you see it in the wild, you'll recognize what it is you're looking at. Now let's talk about list operations, or things that we can do with a list once we have it. By that, I mean things like adding items to a list, removing items from a list, splitting a list in half, sorting a list, reversing a list. There's a lot of things you can do with lists in Python, and we won't cover everything, but let's just go through some of the most common operations. Often, when creating a list for the first time, we don't always know ahead of time what all of its contents are going to be. Most of the time, I actually create an empty list when I'm writing an application. And if you want to do that, as we saw before, you just use the square brackets without putting anything inside it. So now we have fruit basket as an empty list. And once you have your list, you can add items to it one by one by using this built-in append method. So you type the name of your list, then .append, and then you open the parentheses and type in the item that you want to add. So here I can type in a variable, or I can type in a value directly, like a string, as in this example. So now if I've added 3 items to the list, how can I check how big my list is? How do I know how many items are currently inside the list? It turns out Python gives us a built-in function to help us find the size of a list, and that function is called length, or it's actually shortened to len, which stands for length. So to use it, you type length and then open the parentheses and then put your list inside. And that will return an integer, which is going to be the size of the list. And you might be thinking this is a bit weird because previously we just saw append is a method of the list, because then we went fruitbasket.append. But now for the size, it's a function that's outside of the list. So we do length and then we put the list inside that function. And I don't really know why there's that inconsistency, but that's just the way it is in Python. You can also remove items from a list, and there's several ways to do this. One of the easiest ways is to use this inbuilt remove method, and then in there you put the value of the item you want to remove. So what will happen is it will go through the list one by one until it finds that item. The first time it finds that item, it will remove it from the list. So if you have multiple instances or occurrences of that item within your list, it will only remove the first occurrence. But if you remove things from a list this way, it's not very efficient because it actually has to go through every item in that list to check if it exists. So if you have 1 million items in your list, that's quite a lot of extra work it's doing. Instead, the most efficient way to remove something from a list is to use this pop method instead. And this will simply remove the last item from the list. And that doesn't need to take a lot of time because we know that the last item is right at the end of the list and we can just remove it without having to scan through the list to find the item. Now, obviously that has limitations because it does mean you have to design your list and your data in a way that when you remove it, you only care about removing the thing at the end. So it does make it harder to design and harder to think about, not as flexible to use as the remove method, but it is the most efficient. And if you know a specific index of the list that you want to remove, you can do that too using the pop method. For example, if I wanted to remove just the first item of a list, I can pop index 0. So I'll just type fruit basket pop 0, and that will remove the first item. In addition to removing the item from the list, the pop method also returns the item to you, making it available for you to use. Imagine I type something like this, fruit basket, and it's got the apple, banana, and the carrot, and then I type fruit equals fruit basket dot pop. Now, the value of the item that was popped, in this case the carrot because it's at the end of the list, will be stored in fruit, because usually it's very common that when you remove something from a list, it's because you want to do something with it. So by using pop, you can both remove it and have it available for you to use. Now let's go over to our code editor and apply what we just learned. So I'll start by creating an empty list for my fruit basket. And by the way, when you're using something like VS Code or any smart editor, if it knows that the variable you're working with is a list, when you type this dot, it will suggest you all the things you can use with the list, so all the inbuilt methods. And you can see there's quite a lot of them here. So if you struggle to remember all the inbuilt methods you can use with a list, that's one of the ways that the editor can help you. So here I'm going to append. So now I've created an empty list and I've appended 3 items to it, and I'm going to print it. So if I run that, I'll see that it has 3 items. Now what happens if I remove the banana? So I'm going to copy this line here before I print it, and I'm just going to turn that append into a remove instead. So I'll print the fruit basket before, and then I'll print the fruit basket after I remove it. If I hit save and I run that, you can see that the banana is removed. What happens if I add 2 bananas? So let's just copy this line, and then I'm just going to paste it right after the carrot. I'll run that again, and you can see now the original list has 2 bananas, and after I remove it here, it removes only the first occurrence of the banana, so the second one remains. And now let's try popping an item from a list. So I'm going to type fruit and then equals fruit basket dot pop. And here I'm going to print fruit basket first, and then after that I'm going to print the popped fruit. And then if I run that, my fruit basket now has just the apple and the banana. And if I print fruit, then the carrot is stored inside this variable. And if I want to pop a different fruit, let's say I wanted to remove the first one, then I can put the index here. So let's put 0. And then I'll run that. And you can see that now my list has the banana and the carrot, but not the apple. And the apple is returned to us as the fruit. After you've popped this item from the list, after we've popped this apple, does the banana become the first item, or is the first item just empty? Well, you could already see here from the list that there's no empty slot at the beginning, so everything in the list kind of shifts down 1 to fill that popped item. So now let's just delete this and print fruit basket at index 0, just to see whether or not the list has really shifted. So if you press that, you'll see that fruit basket 0 is now banana instead of the apple, or instead of something being blank. Because we've popped the first index, everything else just kind of shifts down. So that covers the basics of using a list in Python. But there's actually a lot of built-in methods and shortcuts to make working with lists really productive. So let's take a moment to run through those things quickly. One of the most useful things for me is using a negative index with a list. So remember how the number that we put inside that square bracket corresponds to the position of the item in the list? Well, it turns out it's also really useful to access lists from the end of the list. For example, if I want the last item in the list or the second last item. So we can already do that with what we know, just using a bit of math, getting the length of the list and then subtracting 1 or 2 to get either the last item or the second last item. But it's actually quite a lot of stuff to type out, so Python's given us this really handy shortcut where if you put -1, you get the last item in the list. So if I have a list like this, then I access index at -1, it's going to print blueberry because that's the last item inside the list. And then to access banana, I can use index -2. By the way, I also encourage you to try out all these code snippets inside your code editor as well, just so you can get some hands-on experience with them. You can also reverse a list by using the built-in reverse method. So whenever you want to flip the list around so that it's in the opposite order, you can just type list.reverse or whatever the name of your list is, and then .reverse, and then that will reverse the list. Similarly, you can also sort a list. So if you have a list of numbers, this will sort it in ascending order. And if you have a list of strings, it will sort it in alphabetical order. So if you want to sort the list, then use the sort method by typing the name of your list. For example, mylist.sort. and then Python will sort the list for you. You can also slice a list in Python using the square bracket notation. This will give you a new list with the items in the specified range. And it won't modify the original list or it won't destroy it. It's just going to create a copy with items inside the range that you specify. So in this case, I want the first 3 items. So I've specified the range from 0 to 3. And to do that, you separate it with the colon. So if I type my list and then open the square brackets and then 0:3, I'll get a sliced list that begins at index 0 all the way up to, but not including, index 3. So when I do this, I get items at index 0, 1, and 2. Remember, I don't get the last index. That is not included in the sliced list. And because this one can be a little bit confusing to understand, let's hop over to our code editor and play around with it a little bit. So I've got the code here just from the example, and if I run it, you'll see that it returns 2, 4, and 6, which are these first 3 items here, because this is index 0, 1, and 2, but then we don't include index 3. Now if I wanted index 3, I actually have to bump up my range, so from 0 to 4, and if I run that, now I get all 4 items. And if I move the first index up, so I move that to 1, now I'll get these 3 items. And also, just to demonstrate that the original list doesn't change, we're going to print that as well. So if I run that again, I see that my slice list is this subsection of the list, but the original list is still the same. Now, another thing you can do with a slice list is that if you want to slice it from either end, for example, if I want the first 3 items or the last 3 items, I don't need to provide the range at the end of the list. So if I wanted the first 3 items, well, I've shown you already that you can do it like this from 0 to 3. And if you run that, that is the first 3 items. But I don't actually have to write 0 here, because if I delete that, Python will assume that I want the list all the way from the left side to index number 3. So let's see that if it works. And here it still works the same, so I still get 2, 4, and 6. And if I change that to 2, then I'll only get the first 2 items, and so on. Similarly, if I don't put anything on this side, it's going to assume that I want to slice anything from the start all the way to the end. So if I want the last 3 items, for example, I could do -3. Remember, because we can use a negative index to count backwards, and then just slice it all the way to the end. And then if I run that, I get the last 3 items. I could also use a positive index. So here, if I use 2, it'll be slicing from 0, 1, 2. It'll slice from this one all the way to the end as well. And that works too. Now, finally, if I don't put any of those things, so if I just put a colon, it will basically slice the list from end to end. And you might be wondering, why would you ever want to do that? So this basically is just the same list. Well, it's actually pretty useful because when it does the slicing operation, it gives you a new list, which means that you essentially clone the list. And it's very common that you want to do something with a list, but you don't actually want to modify the original list. Like, you want to keep that state in case you need it later. So here I've cloned my list. And just to demonstrate that, let's remove some items from the list. So I'm just going to pop one item out of the list of my slice list. And then if I run that, my slice list has the last element removed. But now if I print out my original list, you'll see that the item inside the original list still remains. That's because when I do this thing, it actually clones the list. So if you ever want to modify a list, but you don't want to affect the original copy of the list, then remember this as a trick that you can do to clone it. So now you've learned about lists, it's time for another coding exercise to apply what you've learned. Imagine you have a list of shopping expenses for the last month, and we want to find the amount of the top 3 biggest expenses, and we want that as a new list. So how would you do that using the things you've learned in this chapter? So for example, if this is your list, then the top 3 expenses are 250, 160, and then 92. The result that we want to create a new list with those 3 numbers. How do we do it using the list operations that we've learned in this chapter? So have a look at the sample code and pause the video and try it out yourself. And once you've given it a go, then resume to see my solution. So if you're ready for the solution, this is how I would go about solving this exercise. So first, I'm going to want to create a copy of the list because I'm going to assume that I still want to do other things with my shopping expenses and I want to maintain that order. So I don't want to modify the original list. So I'm going to create a new list and I'm going to call it shopping expenses copy. And if you remember, we can do that using the slice operation. And as a general debugging tip, at each point in my program, I actually like to print out the progress as well, just so that we don't go too far ahead of ourselves without knowing what's going on. And when I run it the first time, it's still the same. Okay, that's good. I want the top 3 expenses, so I need to sort the list. So let's sort it. Remember, we can use the sort method, and that will sort the list that we call it on. It will sort it in place, so it won't return a new list. So yeah, just something to call out that these two things are different. This one returns a new list when I do that here. It doesn't modify the existing one, but this is the opposite. This doesn't return anything, but it sorts the list in place. So let's just take a pause to try that out quickly. Like if I assign that value to X and I print X here, and let's run that, you'll see that I get none. So this actually returns none, but the list itself gets sorted. Okay, so we'll go back here, that. And now I want these last 3 items. Actually, I want them in descending order. So now I've sorted the list, but it's in ascending order, so I can reverse it. So let's go ahead, copy that again, and then I'll use the reverse method. And then when I run that, I have all my expenses from the most expensive to the least expensive. And now I just want the top 3, so I just have to slice this. And remember, we want the first 3, so we'll open this up. We don't need to specify the first index because when we don't specify it, it'll slice right from the sort of the boundary of the list, which is the beginning in this case. And then I wanted to stop at index 3. So let's print that, and there we go. So now I've sorted the list, and then we sliced the top 3 elements, which is the top 3 expenses. So that's how we end up with the top 3 expenses from a list of unsorted expenses. I hope you now feel comfortable with using lists in Python and that you understand how you can use them to work with collections of data rather than individual variables. See you in the next video where we're going to talk about loops. A loop in Python will let you repeat the execution of your code in a sequence. This is especially useful with a list where you might want to go over each item in the list and then do something specific with that item.